First thing we're going to do is open a new project. I'm going to use a monogame cross-platform desktop project. I'm just going to call it Platformer. You can call it whatever you want. I'll just clean some of this up. I'll be back in a second. So all I did here is tidy this up, add some titles to make it easy to identify where you are in the code. I changed this to just a key press for escape. You should never make a final release game that exits on a single key press. So next we'll go up here to the name of your game. Right click, add a folder. We'll call this one user interface. This is where we'll put our heads up display as well as our input module. Start by adding a class. Call it input. Add. And we'll go keyboard state. Right click, resolve. X and A. Keyboard, old keyboard. And we'll have it keep track of some other states like shift down, alt down, control down. Okay, just fast forward a little bit. Oh yeah, let's make this one public. And we'll start a constructor. I don't know if there's anything we need to do in this right now. We want to disable Windows key in the future, or not. We can't really do macros. We can do something kind of similar. Method implementation, compiler services, options, aggressive inlining, and then we'll have something that checks to see if a key was pressed or tapped. So if keyboard is key down, okay, and the old keyboard will return true, otherwise we'll return false. And we'll make another one just to simplify how things look to see if the key is down. And we should have something that updates the key status. First we'll have all the old ones equal the new statuses. And we'll need to get the current keyboard state, get state. And then we'll have to set the current ones to false. And then we'll check their current status. Or is key down, right shift. Then we'll say shift down, down equals true. So just added the same for the other ones. And we'll say if the shift down is true and not the old shift down, then we know it was a shift press or shift tap. So we can set that one to true. And we can do the same for the other two. That's our input class. I always like to save right away. So now we'll go back into game one. We'll add our input class. Okay, I'm just going to take this out. You could leave it in there and then just add the using for it, but since this isn't going to be a huge project, I'm just going to take it out so that the namespace is just platformer, and then I don't have to say using platformer.userInterface. I'm going to create a new one and initialize to new input. Down here we can switch this imp.update and if.keypress, which makes it a little neater and smaller. Escape, exit. Normally we do want it to go into a menu. Okay, so next we'll set up the display parameters. Put in some constants for screen width. This will be our target resolution. Boolean, full screen, let's say it's false. The target resolution is the standard resolution that we want the game to be made for. So you could use a lower resolution, probably a sampler state of point clamp, to make it look more retro. If you want it to be made for a high resolution, you could set these higher. I'm going to add presentation parameters here. That'll come in later for getting information about the actual display mode that was set by the device. Certain ones that you request might not be compatible, so it's always good to check to see what you got if you are actually using full screen and you requested something that the device couldn't support in full screen. It'll give you the closest match. Also going to make a couple of statics, screen width and screen height. They'll be the target resolution. And screen center we'll use to keep track of the corner of the center tile on the screen, which will be useful for scrolling the tiles. So it's not actually the actual screen center. And for convenience, we'll put our We'll put the screen rec as the rectangle that represents our target, and desktop actually matches the actual device's display format or your back buffer, because what it's going to do is we're going to render everything onto a render target that is our desired resolution, and then we're going to stretch everything out to fit on our actual device's display resolution. We're going to do this in borderless windowed mode because it'll look like a full screen mode, and it'll prevent possible conflicts with other programs operating under Windows. Some security software can disrupt full screen mode programs and sometimes crash them. We also need textures for a background. These are texture 2D format, far background, and mid background. And we'll need a tiles image that stores all the tiles for our level, like your platforms, your grass, your trees, and stuff like that. We'll have stuff that keeps track of positions, like our background position. Because of the way I'm going to do this, I'm going to be changing the sampling source from the texture, which is why I give it its own texture, so I can use wrapping and change the sample source with a wrapping state, and that way I can scroll it through the memory without actually moving its physical location on the screen. Also, we're going to need a render target. For our standard target format, let's call it main target. This is what everything will be rendered on before it's stretched out and applied to the back buffer that matches the desktop or device's resolution. Let's go down to the constructor. First I'll have to get the initial screen width, which is a graphics adapter, default adapter, current display mode, make it a little bit smaller. Same thing for the height. We'll set some of the parameters for this during the construction of the graphics device manager. Back buffer width, we're going to set it to the default width, whatever the device is set to when the user went in the program. Oh yeah, this should be a comma, not a semicolon. Same concept here. Is full screen preferred stencil format, depth stencil format. Since later on we might want to use the depth stencil format, I'm going to give it a format of depth 16. We don't need a whole lot of precision. That could come in handy for occlusion of certain effects. Oh yes, this should not be a semicolon. And then you'd put your semicolon here. Make sure to set the window to is borderless. True. If you do decide to have a border for your window, it's good to have something to handle when the user clicks on the close button on the top right hand corner, because if you don't have something handle that, you could just end up exiting the game. Same with your pressing escape. You don't want to just exit the game without the user having a chance to save it or to say, no, I didn't want to exit the game, that was an accident. So we'll set up our main target that we want to put everything on before we put it on the back buffer. Graphics device. And this is target resolution we want. And as I had mentioned, we're going to get the graphics device's presentation parameters. And we'll keep track of the format here for now. We may as well store for easy access later the screen width and height for our main target. Technically it's not the display screen. Technically it's the resolution we're trying to work with. The desktop rec actually does represent the device's actual resolution. And I'm giving it the presentation parameter, back buffer width, back buffer height. There's always the off chance that if you're in full screen mode, it's possible that the requested resolution is not supported, and it would give you something similar. So I always get what the actual presentation parameters returned are. And we'll get the screen rect, which is actually the main target's rectangle. Screen center is a bit misleading. I'm actually getting an offset, or I'm actually getting a position that's 32 to the left and 32 up from the actual center of the screen for the purpose of using this parameter for tiles. Because see, technically if you wanted the screen center, you could say screen rect dot center, and that's your actual center. So the tiles are going to be 64 by 64. And to have a tile centered around the center point on the screen, the center of that tile needs to match up with the center of the screen. So it would be, its corner would be 32 to the left, 32 up. So then its bottom right corner would be 32 to the right and 32 down. This is not really loading stuff. This is initialized stuff. So it was a mistake to put this in here. I'll take this all out of here and we'll put it in here instead in initialize. Okay, back down to load. Let's load some graphics, far background, content, content.load as a texture 2D background. I'm calling it mine background stars because that's what I named the image. And the mid one, background content, same sort of thing as mid background. And the tiles images as tiles 1. Whatever you named your tile set, you can make your background in any program you want. Once you've made your background, you'll want to make it into a seamless scrollable background. So to do that, you'd make a copy of the layer, and if you just want it to scroll seamlessly horizontally, you'd make 2 copies and put them together like so. And then there might be a seam right here. In this case, there's no seam because it was made seamless to begin with. And where your seam is, you can use this. You got to merge the 2 layers together. Once you've merged the 2 layers, but what you can also do is use a clone stamp and set it to like a softer brush, opacity 30-some%. Select where you want to extract copies of painting from and just kind of brush in the stuff that you'd like to cover the seam with. The same concept would apply if you wanted to scroll in the vertical direction as well. Once you got this one done, you could copy all of it, paste a copy down here, blend the 2 seams together. That way it could scroll in all directions, and it would do so with no visible seams. So hypothetically, let's just do that. Duplicate this layer. And you want to hold down Shift when you drag a copy of the layer so that it goes straight. You want to merge the 2 layers together with merge down or merge layers. And the same sort of thing. Hold Alt to pick where you're going to copy the stamp brush from. This is a terrible seam blend. Obviously you'd want to do something a lot better than this. When you get close to the edges though, you want to be careful. You don't want to be smudging around or doing clone stamping near the edges, because then you start adding these little pocket seams. For the middle background, I chose to do additive blending. You don't have to do additive blending. In your sprite batch begin, you can change the blend state to alpha blend. If you want to do alpha blend, you'd have to make a copy of this layer and either erase all this or open the blending options and adjust the slider for this layer. Hold Alt and adjust this one to kind of fade the way the black is affected, and that removes the black from the image. We're going to use additive blending, so it's going to ignore the black anyway. Pure black is going to be fully transparent and colors are visible, but they will be additively blended to the background. So obviously adding zeros is going to not be adding anything, and adding these colors to whatever the pixels behind them are will brighten those colors of the pixels behind it based on what these colors are. So you'll have these semi-transparent sort of glowing pink clouds going over top of everything. This is obviously scrollable in all directions. We don't have to do any seam work with this one. So I threw together a sort of cheesy little tile map. In preferences, guides, grids, slices, most programs have these guides that you can set up. I set it up for every 64 pixels, and I have it deactivated right now, so I'll hit Control quote, and it shows the grid lines as guides. Control plus to zoom in, and if you don't have the window open already, you can go to info, and again, other programs have ways of finding out where the pixels are. Later on we're going to be setting up tiles, and this is sort of the region that I'd want the character to be able to jump off of. So I'd set it up so that this is the corner, and the offset is the distance from here to this left edge, and from the corner to here, and the tile would be a 1x1 tile, so 1 wide, 1 high. These ones, the offset would be 0, 0, tile would be 2 wide, 2 high. Some of these I only want it to occupy 1 tile and they're just background images, so your tile might be like here, and then your offset would be distance from this edge to here and this edge to here, so it would be a negative offset. Here, for example, maybe we would want it to be a 1x2 so that you can't put anything within these 2 tiles, but you can put them here. That's the reason why I'm not making it occupy all these tiles, is so that you can put other things in the scene. I'm probably just going to make it occupy this sort of tile right here, and then just tell it that the offset is negative whatever and negative whatever this distance is from here to here. And you'd create each of these images independently in another canvas, and then you'd copy and paste them into here and position them so that they line up with your grid in a way that you're comfortable with. To do your normal map of your crystal, what you can do is you can Control Shift copy, Control Shift paste, grab your move tool, hold shift, move it over. Make copies of each color channel, your green, your red, your blue, and then use the eraser tool and use some opacity, some less opacity, so it's not erasing as much, it's erasing much softer, and just sort of do a blend erasing of each layer, like the red layer, the blue layer, the green layer, so that your red is the light coming from the upper right, your green is where the shadows are going to be, and blue's kind of in between. You can do it that way, and there's other software out there that you can use that will automatically generate normal maps for two-dimensional images. If you wanted to get really fancy and make the normal mapping really accurate, you could actually model this in 3D and then have it cache or burn a normal map from a 3D rendering. Go down to draw. We can remove this. We don't need to clear it because we're going to be drawing right over the buffer anyway. But before we draw to the back buffer, let's draw everything onto our target resolution. The game is going to be made so that everything will fit nicely onto this main target, and then we can stretch to whatever display resolution we want. We'll put our draw stuff here, and then anything that's been drawn in there, we'll draw that onto the final back buffer, which does page flipping and makes our animations look nice and smooth. We'll draw the main target to the back buffer, but first we'll have to set the rendering to the back buffer. The render target for that, just set it to null, and then it knows to go to the back buffer. And we'll set the blend state to opaque. We don't need any transparencies. It's just going to write right over top of it. Doesn't really matter. We'll just say linear wrap. Stencil state will be none. Rasterizer. Don't need to call anything, so just say call none. The culling is more for 3D stuff. If the polygons that represent the images that you're going to draw got flipped upside down and you had culling on, then they'd be completely see-through. But that would be more for another lesson. So we'll copy our main target as though it's a texture to the destination rectangle, that is our desktop rectangle, matching the device's actual display resolution. So that'll stretch everything out over top of our desktop window as though we're in full screen mode, but it's actually a borderless window mode. Okay, then we'll draw our far background. Deferred. Blend state is opaque. Sampler state. This is important. We want it to be linear wrap this time, because it's a wrapping background. It's wrapping in the memory where it's sampling from. Say your sampling would be 0 to 100. Say your x-coordinate set to 305 or 407 or something, or 417. It would actually be sampling from 17 because it ranges from 0 to 100. So it's kind of like it just wraps around in the memory. So then we'll just draw it. Draw our background. Our target destination is the screen rect, and we're going to be sampling from based on the background position. So we'll create a new rectangle for the source, cast it to integer, because we're using a vector instead of a point. So we got some more precise movement of the background. And we're not scrolling vertical, so we're not going to use the Y in this one, not for the far background anyway. And we'll set the width and height of it, of the source rect, the same as the texture. And color.white just means to draw it normally. It doesn't need to be colorized or have extra transparency or anything. And we'll end that batch. We'll start a batch with different states for the mid background because I'd like to use additive blending. Blend state additive. This will also need sampler state to be set to linear wrap. If you were trying to make it look more retro, you probably want to use point clamp or point wrap. We want to smoothen it out, so we're using linear wrap. And mid background. And this rectangle will be the same, except we want this to be able to scroll vertically as well. And we don't want it to scroll at half the speed. So I'll copy this, paste it here, and this one will be the Y direction. We'll put in a little bit of code so that we can test it. So if we have a, we'll go key down, keys left, and we'll say background position X. Do the same for the other directions. Change this one to minus, change this to Y, Y, minus. Go to content, double click on it, and we need to add the content. So I'll add the content to this folder by saying edit, add. In this case it's existing item, and I already put them in that folder. I'll add all three at once. Add a link to the file. Same for all. Build, save it, yes. Alright, so now we can test it out. When I hit right, it scrolls left. When I hit left, it scrolls right. When I hit up, everything else goes down. If I go down, everything else goes up. It's kind of what we expect. You'll notice the effect of the additive blending as it goes over top of the sunset in the background and over the stars.